if we were to build triangles perpendicular to the x-axis and with their base between f of x and x-axis, what would the volume be equal? And so typically everybody just remembers a certain formula that has like a radical 3 in it, and they just memorize that formula and keep using it. But I think it's a lot easier if you just knew why it actually worked. So if we were trying to construct triangles between x-axis and f of x, let me sketch one in. Equilateral triangle. So the base would be an f of x. And so the height should, so if we were going to make this triangle, the value of the base, and if I draw it out here, this equilateral triangle, the base should be f of x, right? In fact, all the sides should be f of x, the value of the function at that specific point, because it's an equilateral triangle. The question is, what is the height? And that's where it's not so simple. The height, well, if it's an equilateral triangle, then all the sides are the same, which means that all the angles have to be the same. And if there's 3 angles, so 3x must equal 360, right? Because there's 360 degrees, or sorry, 180 degrees. 180 degrees in a triangle. So if you divide by 3, you will find that each angle has to be 60 degrees. So all the angles are 60 degrees. And then if you split this upper angle, you bisect it, then this angle is 30 degrees. So, and then if you were to just look at 1/2 of this side here, just 1/2 of the side, it would be 1/2 f of x in length, right? So now what we have is we have a 30, 60, 90 triangle. And we want to know what the height is, right? H. Well, if you know the hypotenuse is f of x, then the short side is opposite the 30-degree angle, which is 1/2 of f of x. And then this middle side, opposite the 60-degree angle, is always radical 3 times the short side. So H equals, sorry, I'm losing here for a second. So it should be radical 3, so times 1/2, so over 2 f of x. That's equal to h. So now if we want to start writing volume here, we just wanted to look at that first triangle, and to make it a little bit more understandable, it's not really a triangle we're talking a triangular prism. And I always forget to write the interval. We're starting at point A, and we're ending at point B. That's the area, or the volume we're interested in building triangles. So volume is equal to, well, so what's the volume of our first little prism here? And let's say this triangular prism here has a width of W, just for convenience. So what's the volume of any triangular prism? Well, the volume of any triangular prism is going to be 1/2 base times height that'll give you the triangular base, and then times length. And in this case, I'm talking about W as the length. Okay. So the volume of the first one is going to be 1/2 times the base. What is the base? Well, the base is f of x. Times the height. We just said the height is radical 3 over 2 f of x. And so times radical 3 over 2, and then this shouldn't be x here actually, because we're looking at just this first prism, which should be A, right? So that should be f of A. And then lastly, so 1/2 base times height. Now that's it. So that's good. So that would be the volume of our first triangular prism. If we wanted to make a second triangular prism here, perpendicular to the x-axis, then you would find that, so it would still be 1/2 base times height. Actually, up here we forgot one thing. There should be a W. Should be times W to get that width, right? And so the next one will be 1/2 base times height 1/2, and then the base is f of, this time though we're talking the point a plus w, 1/2 f of a plus w times, now the height is going to be radical 3 over 2 f of a plus w. And then the whole thing will be times the width. And so what you'll find with all these problems, excuse me, I'm going to move this a little bit. What you'll find with all these problems is that if you look at the generic formula for the integral, this limit of this infinite series, you'll see that really all you're doing is plugging in a certain operation for f of x here, right? And if you look in this case, what you're doing is you're taking, let's say this entire thing here could be represented as f of a. And then to go from f of a, you just replace the a with an x to get to f of x when you plug it into an integral. So right here, if you were to take this to f of x, you would take this whole thing up here, you would just replace the a with an x. And then I'm just going to simplify this, so it'll be radical 3 over 4 times f of a squared times w, and this shouldn't be a anymore because now we're turning it to an x, so that should be x. And this, my friends, is what you plug into the integral. So this will just turn into the integral from a to b of radical 3 over 4 f of x squared times w dx. And w goes away because you're taking the integral. So what I was about to write here is write out this whole long thing. And this is actually the definition of integral, and this is what really makes sense. But there is a quick way to just look at the generic formula and see how that turns into the integral symbol, because then you can plug this integral symbol